Okay, class, for those of you that like to do your fractions in a different way than finding the least common denominator, most often the people that like to multiply the denominators, I'm redoing problems 7 through 10 and 19 through 21 from the review for the competency exam. So, let's get started here. The first thing we would do to find the common denominator is multiply 4 times 12, which we know would give us 48. So that would be our common denominator. Now to get the numerator of the first fraction, we'll multiply this numerator times this denominator, the first numerator times the second denominator, and that will give you your new numerator. 3 times 12 is 36. Now we go for the second fraction. We take this denominator of the first fraction times this numerator of the second fraction, and that gives us our second numerator. 4 times 5 is 20. Now we add them together. 36 plus 20 is 56, and we carry over our 48. Now, everyone in the class told me they know how to do the prime factorization. So what we're going to do here, we're going to go off to the side and do the prime factorization of 56 first. The prime factorization of 56, we know is 8 times 7. Now 7 is prime. Now we will break down 8. 8 breaks down to 2 times 4. And then the 4 breaks down to 2 times 2. So the prime factorization of 56 is 3 2's and a 7. That is the prime factorization of 56. Again, 3 2's and a 7. So that took care of 56. Now the next number we're going to use is 48. So we'll take the prime factorization of 48, which is 6 times 8. Now we know 6 breaks down to 2 times 3. And 8, if we look up here, when we did 8, we got 3 2's. So 8 breaks down to 3 2's. So our prime factorization of 48 is actually 4 2's and 1 3. So we'll put that here, 4 2's and 1 3. Now, they have 3 sets of 2's in common, so we simplify those out. And our final answer here would be 7 over 6. Now, since this didn't start off with mixed numbers, or they didn't ask for mixed numbers, this will be our final answer, which would be 7 6. Okay, now let's take a look at number 8. We multiply these denominators. 12 times 10 we know is 120. So our new denominators would be 120. Now we know this first fraction here still will be negative. Now we do our multiplication. 7 times 10, which gives us 70, will be the first numerator. And then 12 times 3 gives us 36, will be the second numerator. Now we will add them. We have negative 70 plus 36, which would give us a negative 34, all over 120. Now what we need to do like we did over here with the prime factorization. Now what I'm going to do, since there's more space here, I'm going to use this space here. First I'm going to do 34. 34 breaks down to 2 times 17. So this is the prime factorization of 34. So we still will put our negative, but our numerator would be 2 times 17. So that took care of the 34. Now we have to do the 120. 120 breaks down to 12 times 10. 12 breaks down to 3 times 4. And 3 is prime. And then 4 breaks down to 2 times 2. So that takes care of the 12. Now the 10. 10 is 2 times 5. So now our prime factorization here, we have 3 2's, we have a 3, and we have a 5. Now we simplify out what they have in common, which is only one set of 2's. So to be a negative, the numerator would be 17, and our denominator is 2 times 2 is 4, times 3 is 12, times 5 is 60. So this is your final answer for problem number 8. Now we scroll down here to problem numbers 9 and 10. Now this time we're dealing with whole numbers and mixed numbers. So this is what we would do. First of all, this 8 would become 8 over 1 minus, we would change this mixed number to an improper fraction. Our denominator would be 7, and our numerator would be 2 times 7 is 14, plus 5, which is 19. So, now we multiply these denominators. 1 times 7 is 7. Now we do our cross multiplication. 8 times 7 is 56, and 1 times 19 is 19. Now we subtract. 56 minus 19 will give us 37. And we'll have 37 over 7. Now 37 is a prime number, and 7 is a prime number. But since we started off with a mixed number here, we have to write our answer as a mixed number. So we would take 7 into 37. 7 goes into 37 5 times. 5 times 7 is 35. And 37 minus 35 is 2. So we have 5, remainder 2. So our final answer here is this 5 will be our integer. Our denominator will remain 7. And our numerator will be 2, which is the remainder. So our final answer here is 5 and 2 7ths. Now we move over here to problem number 10. Now remember, we need to change these mixed numbers to improper fractions. But before we do that, let's do this. Let's go off to the side here. This could make it a little easier. Now, if this fraction actually becomes larger than this fraction, then we don't have to bother these two integers here. So let's do this. We have 1/8 minus 2/5. Now we multiply our denominators. 8 times 5 is 40. Now we cross multiply. 1 times 5 is 5. 8 times 2 is 16. Okay, now we have a little bit of an issue here. This first fraction is smaller than the second fraction. So what we need to do is this here. First thing we're going to do is write our 31. And then since 1/8 became 5/40, this 5/40 will go with the 31. And then it'll be minus. Now we will have our 17. And 2/5 became 16 over 40. Now what we need to do here, we need to borrow 1 from this 31. That will make it 30. Now your new fraction here, your denominator will still stay 40, but your numerator, remember what I told you all before. Of course we know we're going to add 40 over 40 to 5 over 40. But I was telling you that an easy way to find your numerator is to take this denominator and add this numerator. 40 plus 5 is 45. That will be your new numerator. Minus 17 and 16/40. Now we subtract. We have 45 over 40 minus 16 over 40, which gives us 29 over 40. And then we subtract the integers. 30 minus 17 is 13. So it'd be 13 and 29 over 40. Now we scroll down here to problem number 19. Now problem number 19, we have to find the common denominators and we're going to multiply them. But first, let's just take this parenthesis here. We will have 1/6 plus 1/2. 6 times 2 gave us 12. So 12 is our denominator. We cross multiply. 1 times 2 is 2. 6 times 1 is 6. So this will give us 8/12. Now we could simplify this 8/12. We already figured out early on that the prime factorization of 8 is 3 2's. And the prime factorization of 12 is 2 2's and a 3. These two simplify out and this becomes 2/3. So this parenthesis here will be 2/3, and we'll bring down our 2 1/3 minus the 2/3. Now we change this 2 1/3 to an improper fraction. The denominator will stay 3. 2 times 3 is 6, plus 1 is 7. So it's 7/3 minus 2/3. Now, we know our denominator will stay 3. 7 minus 2 is 5. Now, we have 5/3. This is an improper fraction. Since we started off with a mixed number, we have to make this into a mixed number. So we would take 3 into 5. 3 goes into 5 one time. 5 minus 3 is 2, and our remainder is 2. So our final answer here is the integer would be 1, the denominator would be 3, and your remainder would be your numerator. So it'll be 1 2/3. Now that took care of problem 19. Let's go over here to problem 20. Now what's nice about problem 20 is this parenthesis is the same as this parenthesis. So we know this parenthesis, after we did everything, became 2/3. So we do not have to reinvent the wheel. Since we know that parenthesis is 2/3, we can write that parenthesis as 2/3. Now look here. We have addition, we have division here, right? So we know according to the order of operations, we do division first. 2/3 divided by 2/3 is 1. So you have 1/4 plus 1. So now 1/4 plus 1, whenever you have an integer and a fraction added together, it'll be the integer and the fraction together. So it'll be 1 1/4. Now we scroll down here to problem 21. Now with problem 21, this is what we need to do. First thing we need to do is this parenthesis squared. We know 2/3 in parenthesis squared is the same as 2/3 times 2/3, which we know is 4/9. So here we will have 15, we'll make this 15 over 1 times 4/9 plus 5 squared is 25, and we will have 3 here in our denominator. Now we can multiply. 15 times 4 is 60, and 1 times 9 is 9, plus 25 over 3. Now before we multiply these denominators, why don't we see if we could simplify this? Now first of all, I need to move down this answer key part here. Let me move that down so we'll have more room here. Okay. So now we go back here. Let's simplify this 60 over 9 if we can. Now 60 prime factorization, we know that 3 times 20 is 60. 3 is prime. 20 breaks down to 4 times 5. 5 is prime. And 4 breaks down to 2 times 2. So we have 2 2s, a 3, and a 5. Now that would be 60's prime factorization. Now 9 prime factorization is 3 times 3. Now what we would do here, off to the side, we would take the 60 over 9, and we will have our 2 2s, a 3 and a 5, in our numerator, and 3 times 3 in our denominator. These 3's will simplify out, and that will give you 20 over 3. So we can replace this with 20 over 3, and make that plus 25 over 3. Now, they have the same denominator. So we know our denominator is going to remain 3, and 20 plus 25 is 45. Now, we could go off to the side and take the prime factorization of 45. That breaks down to 9 times 5, and then 9 breaks down to 3 times 3. So our prime factorization of 45 is 3 times 3 times 5. And we already know our denominator, 3 is already prime. These 3's simplify out. So you will end up with 15 divided by 1, because when everything simplifies out in your denominator, it equals 1. And 15 divided by 1 is just 15. And we're done.